Okay, this page goes with the notes on our right triangle trigonometry. So we're going to use sine, cosine, and tangent ratios to find missing side lengths in right triangles. So let's look at these first ones. We have some algebra equations to simplify here. So 4 is equal to x over 7. We need to get x by itself. So first thing you have to do is get rid of 7 in the denominator. The opposite of dividing by 7 is to multiply by 7. So we end up with 28 is equal to x. For number 2, multiply both sides by 4. 12 is equal to 2x. And divide both sides by 2. X is equal to 6. For number 3, multiply both sides by 7. We get 7x's is equal to 84. Divide both sides by 7. We get x is equal to 12. For number 4, multiply both sides by x. We get 2x's is equal to 5. Divide both sides by 2. X is equal to 5 halves. So sometimes we'll run across problems where there's not enough information to use the Pythagorean theorem. Like for the Pythagorean theorem, you really need to have 2 side lengths out of the 3 to be able to compute the missing third side. We also talked about the special triangles. Like if we have a 45, 45, 90 or 30, 60, 90, then we know about the ratios of the side lengths. But if it's not a 45, 30, 60, or 90 degree angled triangle, then we have trigonometry that we can use, which involves sine, cosine, and tangent ratios. So sine of theta, if this is a theta, is defined as, and let's label the sides here. Little a is opposite vertex A, little c is opposite vertex C, and little b is opposite vertex B. So the sine is opposite over hypotenuse. And if we use theta as our reference angle, the opposite side is A, the hypotenuse is C. So we have A over C. For cosine, it's defined as adjacent over hypotenuse. In terms of theta being on the reference angle, cosine is the adjacent side, which is B, over the hypotenuse, which is T. And tangent is defined as opposite over adjacent. In relation to theta, the opposite side is A, the adjacent side is B. So you get A over B. In terms of side lengths, the sine of A is equal to BC over AB. The cosine angle A, or theta, is equal to adjacent, which is AC, over hypotenuse, which is AC. And the tangent of theta, which is BC, over the adjacent, which is AC. So that's how we can use the different side lengths to set up the ratios. So the side across from the right angle, we call the hypotenuse. The side across from the other given angle, so this is our given angle, the side across from this other given angle side across from the other given angle. If we use x as our given angle, the other given angle is this opposite corner. The side across from that is actually the adjacent side to our given angle. And the side that touches the other angle is the opposite side. Generally, we go with, if this is our reference angle, if this is our given angle, then the hypotenuse is always the side opposite the right angle or the longest side of the triangle. If you imagine standing at the angle inside the triangle, the side that you can touch that's not the hypotenuse is the adjacent side, and the side that you look across at is the opposite side. Now, if we switch reference angles, if you up here at this angle here, standing here, the hypotenuse is still the same. It's opposite the right angle. But now the adjacent side is the side you can touch if you're standing at the angle, and the opposite side is the side you're looking across at. So it's really important we keep opposite and adjacent straight, depending on the reference angles. Okay, we want to solve these for x. Okay, let's look at number 1 here. If you look at our reference angle, x is an opposite side, and 10 is the adjacent side to that angle. So we're going to be using tangent, and we set up tangent of 20 is equal to the opposite, which is x, over the adjacent, which is 10. To solve for x, multiply both sides by 10. 10 times the tangent of 20 is going to be equal to x. Now from the table, the tangent of 20 is 0.3640. So 10 times 0.3640 is going to be 3.64. So rounded off to 1 decimal, we have 3.6. Let's look at number 2. 41 is our reference angle, 11 is a hypotenuse, and x is an adjacent side. So we have adjacent with hypotenuse, that's going to be cosine. So cosine 41 equals the adjacent side, which is x, over the hypotenuse, which is 11. Solving for x, multiply both sides by 11. 11 cosine 41 is equal to x. And using the table for cosine of 41, we get 0.7547. Multiplying it out and rounding off to 1 decimal place, we get 8.3. Let's look at number 3. We have a hypotenuse, and we have an adjacent side. That's going to be cosine. Cosine 56 is equal to the adjacent, which is 10 over x. Now x is in the denominator, so it's going to take 2 steps to get it out of the denominator. We're going to multiply both sides by x, so x cosine 50 equals 10. To get x by itself, we need to divide both sides by cosine 50. We get x equals 10 divided by cosine 50. We're using the table. The cosine of 50 is 0.6428. So x is going to be 10 divided by 0.6428. And rounded to 1 decimal place, that comes out to be 10, that comes out to be 15.6. Wait, rounded to 1 decimal place, 15.6. Okay, let's look at number 4. Our reference angle is a 36. 10 is an opposite, and x is the hypotenuse. So we have opposite hypotenuse. That's going to be a sine ratio. So we're going to set up sine 36 is equal to the opposite, which is 10, over the hypotenuse, which is x. Multiply both sides by x. Sine 36 is equal to 10. X is going to be 10 divided by sine 36. Now sine 36 from the table is 0.5878. And 10 divided by 0.5878 is 17.0, rounded off to 1 decimal place. Circuit number 5. Is our reference angle. X is an opposite. 12 is the hypotenuse. We have opposite hypotenuse, that's a sine ratio. Sine 21 equals opposite, which is x, over hypotenuse, which is 12. Get x by itself, multiply both sides by 12. 12 times the sine 21 is going to be x. Now from the table, the sine of 21 is 0.3584. So equals 12 times the sine of 21, which is 0.3584. And that gives us 4.3, rounded off to 1 decimal place. And thank you. Let's look at number 6. 67 is our reference angle. 6 is an opposite. X is an adjacent. So we have a tangent ratio. Tangent 67 is equal to opposite, which is 6, over adjacent, which is x. Multiply both sides by x. X tan 67 is equal to 6. To get x by itself, we divide both sides by tan 67. X equals 6 divided by tangent 67. And tangent 67 from the table, 2.3559. And that gives us 2.5, rounded off to 1 decimal place for the length of x. Okay, let's look at the inverse problem. Now for these, we solve for the angle that goes with the ratio. So let's set this up. X is our reference angle. 5 is an opposite side. 14 is the hypotenuse. So we have sine with this. We say sine x equals opposite, which is 5, over adjacent, which is 14. So what we're going to do with these is turn this into a decimal, and then we're going to look up in the table the closest angle that we have to the actual number that we get. So 5 divided by 15 is 0.3333 to 4 places. If we go to our table and look down the sine column in our table, we have 0.3256 for 19 degrees. And we have 0.3420 for 20 degrees. And 0.3333 is in between those. It's actually like 77 away from the 0.3256, and it's actually 97 away from the 20. So we might guess around 19 degrees for the value of angle x. Let's look at number 8. So number 8, x is our reference angle, 8 is a hypotenuse, 5 is an adjacent. So we have adjacent with hypotenuse, it's going to be cosine. Cosine x is going to be the adjacent, which is 5, with hypotenuse, which is 8. 5 divided by 8 as a decimal is 0.6250 out to 4 decimal places. If we look at in our table, down the cosine column, to the closest 6250 we have, we get 51 is 0.6293. And 52 degrees is 0.6157. So we've got 53 away from 52 degrees, and we got 43 away from 51 degreds. It's a little bit closer to 51 than 52. We might guess 51.4. So x is about 51.4 degrees. Now with the calculator, there's a process, and I'll show you this on the next one. We'll set it up, even though I'm using the table for these values, because I don't have a calculator available right now. So look at the next one. Number 9. This is our reference angle. 17 is an opposite. 41 is a hypotenuse. So we've got opposite over hypotenuse. That's going to be a sine ratio. So sine x equals 17 over 41. To 4 decimal places, that's 4146. So we have sine x is 0.4146. Now if we're using a scientific calculator for this, we can actually use our sine to the -1 key of 0.4146. And we would enter, as long as our calculator is set for degree mode, it'll give us the angle measurement. Now what I'm doing is using a table of values that have already been computed, and I'm looking down the sine column to find the closest angle to 4146. So 4146 is in between 24 and 25. 24 degrees, the sine is 0.3584. 25 degrees (4226). So 24 degrees again was 0.4067. So in terms of distance, 79 away to this side, and 4146 is 60, 70, is 80 away from this side, so it's almost in between. So I would guess about 24.5 degrees. Now again, this process of the calculator will give you a closer decimal approximation. Let's look at number 10. Here's our reference angle. 8 is an opposite. 5 is an adjacent. So this sets up a tangent ratio. Tan x is equal to opposite 8 over 5. That's going to give us 1.6. And if we do tan minus 1 of 1.6 in the calculator, that'll give us the decimal approximation of the angle that goes with the tangent being 1.6. Using the table, if I go down the tangent column, 1.6003 corresponds to 58 degrees. So 58 degrees, tangent 58 degrees is 1.6003. So we would say 58 degrees is our angle for this triangle. Let's look at number 11. Number 11, here's our reference angle. 7 is an opposite. 11 is an adjacent. So we're going to set up, we have opposite adjacent, set up a tangent ratio. Tan x equals opposite, which is 7, over adjacent, which is 11. That gives us 0.6364, rounded off to 4 decimal places. And if I look down the tangent, so if I was doing this on a calculator, I do tan minus 1 of 0.6364 enter, and that would give me the angle measure. Using the table though, I go down the tangent column to find the closest one to 0.6364, and it's in between 33 and 34 degrees, and it's closer to 34. So I would guess that x is about 6364. It's about 32.5 degrees.
Let's go.
Look at number 12.
That's a job.
13 is the hypotenuse.
That's one.
9 is the adjacent. Adjacent hypotenuse, that's going to be cosine ratio. Cosine x is equal to adjacent. Hypotenuse equals 13. To 4 places, that's 0.6923. And if we look that up in our cosine column, we get 6947 goes with 46 degrees. 6820 goes with 47 degrees. So this is really close to 46 degrees. I might guess like 46.3. degrees for x for this problem. Now if we were using a calculator, we do cosine minus 1 of 0.6923, hit enter, and it will give us the better decimal approximation.